Hello everyone, I am Pavani. I am working as Assistant Professor in CSE AIML Department, MLR Institute of Technology. Today I would like to give a session on language modeling. In previous videos, we discussed already language modeling. There are two types of language modeling: various grammar based modeling and statistical language model. In various grammar based model, there are 5 types: hierarchical and generative grammar, and next lexical functional grammar, Pennian grammar, government and binding. These are all we discussed in previous videos. Today we discuss about statistical language model and a design introduction about statistical language model. In statistical language model, we are using n-gram model. To overcome the probability of 0, we are using 2 smoothing techniques: advanced smoothing, good Turing smoothing techniques. Let's discuss about all these topics. This is the overview of the statistical language models. Come to the introduction. A statistical model assigns the probabilities to sequence of words. That means to assign the probability of the sequence of word in a sentence. These models are crucial for applications like speech recognition, machine translation, text prediction. To overcome this, we are using the statistical language model to find out the frequency of the probabilities of a sentence. One of the most widely used effective approach is the n-gram model in statistical language model. By using n-gram model, we can break the sentence into smaller parts. Discuss about n-gram model. This is a very important one, n-gram model. By using n-gram model to estimate the probability of the sequence of words by considering the occurrence of n word. This is the formula for probability of, to find out the probabilities of the sequence of word. That is probability of sentence equal to probability of word 1, word 2, word 3 and so on, word n equal to probability of word 1, word 2 by word 1 into word 3 by word 1, word 2 and so on up to n minus 1. This is underway. Probability of s equal to pi of n equal to 1. Probability of, this is another formula. It is overall formula. Here wi is the number of words, hi is the history of word. That means we have to calculate the probability of each word based on the previous ones. That means previous word. So in order to find out, we need to calculate the probability of the word, probability of wi. That means wi means number of words, hi history of the word, probability of wi by wi minus 1, I minus n plus 1 and so on, wi minus 1. This is the formula for to find out the calculate the probability of the word. Take the example. Consider 2 sentences. There was heavy rain, there was heavy flood. These are the 2 sentences to find out the probability of the frequency of the word. Come to training model. Here, what is the frequently occurred word? Heavy rain is the frequently occurred word in a database. That means large data sets. So heavy floods somewhat compared to heavy rain. So heavy flood will not more than times will not occur. There are different types of n-grams are there. Type 1, that is unigram, bigram, trigram, n-gram. These 4 are the types of n-grams. That means, what is the meaning of unigram? It means it considers only the independently. That means uni means single. That means considers only single word. It ignores the previous word. It is probability of vi equal to probability of v1, w1, w2 and so on, wn. This is the probability of word I. It is unigram. Means it only considers only single word, not considers the previous word. Take an example. There was heavy rain. There was heavy. Take the sentence. Here probability of what? That means probability of rain. occurring without any context. It means here we are taking the only single word. That means this is the unigram. Come to the bigram. That means it takes the previous word also. That means heavy rain. What is the previous word for rain? Heavy. That means formula probability of Wi divided by Wi minus 1. This is the bigram model. Next one, trigram. That means we can take the previous two words in a sentence. That is rain. Rain is the word. Take the previous two words. Heavy was. This is the previous two words. It means Wi divided by Wi minus 2, Wi minus 1. This is the formula for it to calculate the probability of the trigram. Next, we calculate n-gram. N minus 1. We can take n minus 1 previous words. Take the example. To find the probability of there was heavy rain, probability of S is first divide the sentence into tokens. This is called as a tokenization. There was heavy rain. There are in this sentence there are four words are there. There was heavy rain. Divide the sentence into tokens. Probability of there. Next, that is equal to probability of W1 into W2 by W1. That is probability of W1. That is first. What is the first word? There. Into probability of second word. That is W2 divided by W1. That is was divided by there. Into probability of W2 divided by W1 comma W2. That is W2 divided by W1 comma W2. That is heavy by what is the W1 there comma was. Same like this. Probability of rain. Probability of W3 divided by W1, W2, W3. Like this, we can calculate up to how many words are there in sentence. This is the W3, W1, W2, W3. This is the overall to find out the probability of the sentence. Here there is some drawback is there. Here we are the words are repeating. There was. So to overcome this drawback, we are using bigram model. We are using bigram model. Because why? Because in previous model, by using Markov assumption, it was hard to calculate the properties. Because to database means words are repeating. So that's why this is the drawback to find out. This drawback, we are using bigram model to calculate the probability of the bigram. By using bigram model, probability of there was heavy rain. There was heavy rain is what is the probability of W1 there. W2 divided by W1. W2 3 divided by W2. Like this. That means probability of W1 into probability of W2 W1 into probability of W3 W2. Like this. Probability of W4 W3. Like this. We can calculate the probabilities per sentence in the sentence. Like this. To overcome the previous drawback, we are using the bigram model to calculate the probability of the sentence word in a sentence. In this n-gram model, sometimes the word is not appear. Automatically the data set will show the 0. That means 0 probability. This is not accurate to the speech recognition and machine translation. To overcome this, we are using smoothing techniques. It is a good one smoothing technique. It is add testing, good one smoothing, add one smoothing, and good tuning smoothing. So smoothing techniques. In smoothing techniques, n-gram model are used to handle the, that means to solve the problem is 0 probability. zero probability. Sometimes the word is not appear in database. Automatically the training model will show the 0. So the model will assign the 0, which is problematic for many applications like speech recognition, machine translation. To overcome this problem, we are using advanced smoothing method and good tuning smoothing method. First one, advanced smoothing method. This is a simple technique where 1 is added to the count of every n-gram. Where 1 is added to the count of every n-gram before converting them into probabilities. Before converting it to probabilities, we are adding 1 to the n-gram model. Means 1 to the n-gram. The problem for the formula is probability of Wi divided by Wi minus 1 equal to C of, that means C means count of Wi minus 1 into Wi plus 1 divided by C of Wi minus 1 plus V. V is the vocabulary. Here V is the vocabulary. That means this is the explanation for where C of Wi minus 1 into Wi is count of the bigram. The training corpus. That means training model. C of Wi minus 1 is count of unigram. Wi minus 1. This is V is the vocabulary. That means how many unique words or unigrams are there in sentence. Plus 1 is the smoothing vector. This is the explanation about advanced smoothing technique. Here take the example. I love dogs or I love. This is the here how appear 2 times, dogs 1 time, cats 1 time. To add C of here plus 1, 2 plus 1 divided by vocabulary is 5. That means number of times the words appear. Dogs and cats are words also we can add. This is the formula to solve the problem. Next one, good Turing smoothing. To find out the good Turing smoothing, in good Turing smoothing we can find out the frequency of the word. Probability, that means mass frequency for rare and unseen events. This is a formula F star equal to F plus 1 into NF plus 1 divided by N into F. This is the formula for to find out the frequency of the word, where F is the original n-gram. Next, NF plus 1 is the number of grams that occur F plus 1 times. NF is the occur exactly F times. This is the explanation for the formula. Take the example. Here 2 bigrams that occur 5 times, 3 bigrams that occur 6 times. Here 2 bigrams that occur in 5 times means the frequency is N, 5 is 2. That is frequency N, 5 is the frequency occurring 2 times. Next, N, 6 that occurs in 3 times. To calculate the F star for n grams occurring 5 times is 5 plus 1 divided by into 3 by 2, that is 18 by 2, that is 9. Same like this, you can find out the 3 bigrams occurring 6 times. This is the overall explanation of good Turing smoothing method. This is the overall example for the using bigram model. To overcome the hidden Markov model, we are using the bigram model to find out the probability of a sequence of the word in a sentence. Take the This is the training set contains 3 sentences. The Arabian Nights. These are the fairy tales of the East. The stories of the Arabian Nights are translated in many languages. This is the probability to find out for each word. Take the one example. Probability of the sentence. Here in the sentence, the occur in how many times? Here 1 time, here 2 times. 2 by how many sentences are there? 3. That is 0.67. Take the same like this. Probability of Arabian the. That is probability of Arabian how many times occur? 1 time and 2 time. That is 2 by the how many occur? 1 time, 2 time, 3 time, 4 time, 5 time. 2 by 5, that is 0.5. Like this we can find out the up to all words in a sentence. The probability of these words, this training set is 0.0067. So overall, we discussed about the statistical language model. What is the introduction about statistical language model, and next N-gram model, and next smoothing techniques. This is all overall about the statistical language model and language modeling. In language modeling, 2 are there: various grammar based model and statistical language model. In statistical language model, we are using N-gram model. In N-gram model, to overcome the probability of 0, we are using 2 smoothing techniques: advanced smoothing, Goodwin smoothing technique, add Turing, Goodwin smooth Turing method, and next add Turing method. This is overall about the language modeling in NLP. Thank you.